High school maths, badly summarised. And yes, I said maths because I'm British. Deal with it. Algebra. Algebra is the study of variables. Variables are just numbers, but you don't know what the numbers are. So you use the letters to represent the variable, like x or y, until you know what the number it represents is. Knowing what the variable represents usually comes from solving an equation or a formula, which links the variable together with some concrete numbers. Geometry. Geometry is the study of shapes and how we can manipulate them. Reflections, rotations, translations, and dilations, which I did have to look up but means either enlarging or shrinking the shape, all come under this. Similarity and congruence are really important in high school geometry. Congruent shapes are exactly the same, or are mirror images of each other, whereas similar shapes could be scaled up or down. It also includes weirder stuff like radians, which is like degrees but for people who are good at math, and ways to construct different shapes given a compass and straight edge, which is a ruler without any markings on it. Trigonometry. The bane of my preteen existence. Trig's all about triangles. Sine, cosine, tangent, and the graphs of those functions. They show how a ratio of a triangle's sides changes as the angle between two of the triangle's sides also changes. We usually use the Greek letter theta to represent angles, but if you have lots of angles, feel free to go wild. Sometimes you'll get problems where you have to work out something weird, like the sine of 75 degrees. Thankfully, there's compound angle formula. These let you work out the sine, cosine, or tangent of an angle by writing it as a sum of two smaller angles which you already know the exact values for. Pre-calculus. Pre-calculus covers a lot, so I'm going to break it down into some of the more interesting topics and completely ignore the rest. Complex numbers. The square root of -1 is called I. The I probably stands for imaginary, but feel free to call it interesting or insipid or whatever adjective takes your fancy. Once you've accepted all of high school math as a lie, you can think about numbers which have both a real part, where real means all the numbers we held dear till now, and an imaginary part, which has an I term in it. You can add and multiply them to your heart's content, or even plot them on something called an Argand diagram. It looks suspiciously like the graphs you're probably used to. Conic sections. Cones are cool. I'm from the UK and they don't get a lot of love here, so I was kind of happy this came up. Conic sections are all about the intersection of cones with planes, which are flat sheets that extend out infinitely in 3D space. There's a few conic sections, but my favourite is definitely the hyperbola. It's the most terrifying. Vectors and matrices. A vector is a lot of things, but for today it either represents a point in some space, an arrow pointing to that point in some space, or a collection of numbers. Matrices are just collections of vectors stacked up into a neat rectangle. Well, unless you're a computer scientist. You can also think of matrices as moving about whatever dimensionality space you're in, shifting all the vectors in that space to and fro. Mathematically, we shift the vectors by multiplying them by our matrix. The actual method for matrix multiplication is a bit weird and isn't element-wise, but preserves this idea of transforming the space. Most matrices are invertible, which means you can find another matrix and multiply it with the transform vectors to put them back to their original position. Some aren't, which usually means they squish the space down into a lower dimensionality, so you've lost some information which can't be brought back. Limits. If I approach x equals 0 on this graph from the left, it goes to 0. If I approach x equals 0 from the right, it also goes to 0. We say that the limit of this function as x tends to 0 is 0. If I approach x equals 0 on this graph from the left, it goes to negative infinity. Approaching x equals 0 on this graph from the right, it goes to positive infinity. They don't match up, so we say the limit of this function as x tends to 0 does not exist. A lot of limits is linked to the idea of continuity, which is where the function doesn't have any breaks, gaps, or jumps in its graph. Stats. I don't really like stats, so I'm going to skip it. Maybe I'll make a video about it someday. Calculus. The pinnacle of high school mathematics. Differential calculus is all about finding how steep a graph is at a given point. Back in the day, you'd find the slope by dividing the change in y by the change in x. You get a nice triangle out of it, so that's something. The problem is that most graphs are curvy, so triangles are pretty hard to draw. Instead, we use a whole lot of rules on a given function to produce the gradient function, which we can plug an x value into to give us the exact steepness of the tangent to the curve at that value algebraically. Integral calculus lets you find the area under a graph. You can approximate this by drawing triangles, or rectangles, or trapezia under the curve, but integrals do this exactly with algebra. And there you have it, folks. That's all of high school math badly summarised. I'll face my fear and do stats at some point.